All right, hi. My name's Berndt. I'm going to talk about function as a service, real or hype. I'm trying to give some background on serverless in general or functions, and then, hopefully give a couple demos and give you guys an opportunity to ask me any questions you want. So I don't know what everybody's background is with functions, but I thought I'd start with kind of what is a function. So generally speaking, functions are event-driven. They're unlike a container or a VM that's kind of sitting around like a traditional web app just kind of waiting for requests. They're generally completely idle, maybe even completely unscheduled. And then as events come in, they get scheduled, they get fired. Gives a sort of a better resource utilization model. Also, they're stateless. In order for them to be scaled all the way to 0 and then auto-scaled up to as much capacity as you have as needed, they need to be stateless. Because they have lower resource or a better resource utilization, because they're scaled to 0, you get a better cost model. Also, because the framework, the functions as a service framework, takes care of a lot of the infrastructure, coding, and knowledge for the developer. The developer can focus pretty much solely on line of business code and not on infrastructure, which gives sort of a better developer resource utilization. And traditionally, particularly in the public clouds, they're short duration. In fact, like Amazon Lambda will have a hard limit about how long a function can run. I think their limit is 5 minutes. Well, in the open source world, of course, you've got a little bit more control over the platform and over the environment. And so you can change that as you see fit. So you could have a function that could run for a very long time if you so desire. So this slide didn't turn out quite perfectly. Anyway, so what are use cases for functions? And this slide is really, I'm not going to go through all the items on there, also partly because you can't read some of them. But the point is that there are a lot of use cases. I don't see functions as a service or FaaS as being like sort of a magic bullet to handle sort of your general application development use cases that I think a lot of people are kind of pushing for serverless. And I think that's where, to the question being asked in the title of this presentation, I don't think they're ever going to live up to the hype of being the be-all, end-all for general application development. However, there are a lot of use cases. All of these use cases are things that can be done with functions. Some of them are done very well with functions, and some of them can be, but maybe not. Maybe you shouldn't. Maybe it's better to run on a traditional sort of container or a traditional VM. So I kind of answered a little bit of why functions in describing what are functions. But one of the reasons that people are moving in this direction, it's sort of a progression that's been going on for a long time. We started with bare metal, and bare metal hasn't gone away, but a lot of those workloads, where appropriate, which for VMware's case was the majority of workloads, migrated to VMs when VMware made the VM sort of brought the VM to the enterprise. Now, in the past, I don't know, 5 or 6 years, we've seen containers kind of have that same trajectory where a lot of people, especially with new applications, are containerizing and using orchestrators like Kubernetes to build essentially almost all of their new applications on. And functions is sort of the next step. It's a microservice, well, it's a nano service, let's say. It's breaking the application even further. It's abstracting the infrastructure even further. A developer that's writing a function shouldn't need to worry about, what is a web server? How do I expose my code to the internet? Like, do I use Apache or anything like that? All they're doing is taking some code, submitting it to a framework, and then using the framework to, for instance, enable a HTTP endpoint that routes through to that function. However, functions in and of themselves aren't going to build your application. So this slide is the architecture for a project called Hello Retail, which Nordstrom built, I don't know how long ago, maybe a couple years ago at this point. But it was sort of, I guess it was more of an experiment about, hey, what can we do with Lambda and the surrounding AWS services? And what they did is they built an entire retail application, a very full-featured retail application, using functions as the sole method of compute. And as a whole, I would say this is entirely serverless, and with the definition of serverless being that you're leveraging all managed services and functions. So even though there is state, it's state via a managed database service and queue services and whatnot. And so the developer, from the developer's perspective, they're dealing with state. They're dealing with state, but they're not dealing with infrastructure at all. They're just using managed services, and any sort of business logic is in the form of a function. So, kind of a history. AWS introduced AWS Lambda in November 2014, which actually seems like a long time ago. And then it took another 2 years for Google and Azure to kind of come on board with their own function service. And AWS Lambda is still the predominant public cloud and predominant serverless and FaaS provider today. And just recently, now you're seeing a lot of sort of explosion in the open source and on-premise development. You're seeing, like, we've got Alex Ellis and OpenFaaS. OpenFaaS is probably the most popular open source framework. That got brought on board, I don't know, I guess almost 2 years ago, or less than 2 years ago, early 2017. I'm running a group within VMware to develop a project called Dispatch. We open sourced that just in January 2018. And the CNCF got involved to sort of define, I don't know, standardize some things around serverless, including eventing. They produced a white paper February 18, and then Google just announced something called Knative 1 month ago, which I think is going to have a very large impact on all of these open source serverless offerings, and maybe even some of the public, well, certainly the Google public serverless offerings. And we can talk about that later if we want. So I'll give a quick overview of what Dispatch is, and then I'm going to give some demos. So Dispatch is our sort of serverless framework. We're taking a little bit of a different tack in that we're not just sort of trying to solve the problem of function execution and scheduling and execution. What we're trying to work on is really the surrounding services around the functions that are, well, we believe would be required to make a function service available to an enterprise. And so that means like building an event bus and making that extensible so that you can pull in events from external sources, because functions are event-based and they need to react to events from external services in order to really do anything. We have an API gateway. API gateway within AWS accounts for something like 80% of the function triggers for Lambda, and certainly, building REST endpoints or webhooks is a very solid use case for FaaS in general. If I want to build just a simple like Slack integration, a simple webhook, I don't want to have to worry about like, okay, well now I need to put an Nginx instance on the internet and then manage that and configure that, when I can just use a service. I can use a framework to just take care of that. And I can also use that same service to take care of a whole bunch of functions and their ingress. We've got integration with Open Service Broker, and sort of another way to integrate external services and make those available to functions. And then we've got tenancy constructs and the ability to work with existing identity providers, including Google, GitHub, and VIDM. Basically any OpenID compatible identity provider. So with that, I'm going to go into a demo. This is a little last minute. I thought I was going to be able to have my laptop here, but I'm not, and so I moved over some files, and we're gonna try to do the demo from this borrowed laptop, and we'll see how it goes. So anyways, what I thought I'd start with was just sort of an intro to some of the dispatch concepts and sort of the hello world example. So let's see. I'm going to start with this hello.py. So within dispatch, we have this notion of we have this notion of base images. And base images are just really the operating system and the runtime. And so for this function, which is just basically a hello world, I don't have any dependencies, and so I can just use pretty much the base image, which is is also a image. The concept of image is really a way to take that base image and then extend it with any runtime dependencies. So in this sort of hello world example, I don't have any dependencies, but let's say I had a dependency on we've got here's this image right here, this Power CLI image is an extension of the PowerShell base image, but adding the Power CLI library. And in the same way, we can create, like if we had a dependency on the requests library within Python, we can create a image that contains that dependency. The advantage of sort of managing dependencies in this way is that for functions, I don't need to wrap up the dependencies with my function code. I can just worry about my function code, and the dependencies are captured in the images themselves. So once we've got images and whatnot, to create a function, we just do dispatch. /dispatch create function. Hello. Give it an image. And path to the. All right, so that's being created, and we can see what's going on. Oh, okay. Okay, so it's creating. What's actually happening in the background is we're taking that code artifact, and then we're layering that onto the image, Docker image, and then creating another Docker image which contains both the function and the underlying image. That image, or that function image then can be scheduled by Kubernetes and executed on demand. All right, so it's ready. We've got a path to our Docker image, and then we can now execute that function. Sec. All right, and so we've got our output. Our output is hello, no one from nowhere. If we want to pass input into this function, we can just do that with input, and name. And so now we've got, we've passed in our data. You can see that gets reflected in the input, and then the function code took that input and then created this output string. So now that's all interesting, but you can't really build an application by triggering it from a dispatch CLI. So let's say we wanted to then link this function to an API endpoint. So dispatch, we've got this concept of APIs, and APIs, this is our management of the API gateway, which I sort of showed a little earlier. So dispatch, get API, should have nothing there, so let's create one. Dispatch, create API, get hello. We're going to link it to the function that's called hello. We're going to say, hey, I want to get to it at the path hello, and oops, respond to the get method. So now we've created an API endpoint. We can see that, okay, it's ready. It's going to be available at this URL. I need to now check exactly what host I'm on. So all right, so now if we were to curl this, oh no, that's not supposed to happen. Ah. Oh, it's get hello. Okay. Well. Fundamental dispatch framework. All right. Well, unfortunately, the demo is not working. But the point is that this provides a relatively easy, when it's working, a relatively easy way of basically exposing your functions to HTTP. And this is a way to easily create just about any sort of HTTP interaction. I've got some other demos that may or may not work with regards to creating sort of richer applications. Let's see, like, I don't have. So let's see if this works. Dot. All right, well, I apologize. Not having my demo laptop has made this a little bit trickier than I had anticipated. Anyways, so I'll just end there. We've only got 5 minutes left, anyways. But I'll take any questions if anyone has any questions about Function as a Service in general, serverless, what we're doing with dispatch, and even what we're even Knative, which I had referred to earlier. Say that again. Oh, is it typical that Functions as a Service is using containers? Yes, absolutely. Just about, in fact, every major Function as a Service is using containers under the hood. Even Lambda is using containers under the hood. Yeah, generally speaking, yeah. Yeah, so that I would say maybe not today, but this is something that is actually in progress and being worked on. So there's a CNCF effort within the serverless working group to define a standard called cloud events. And in fact, Azure has already implemented this, and so its event grid product will output cloud events and can push cloud events. And the idea being that with a standard eventing format, now you can all of a sudden, like, basically use services from just about any provider, and a FaaS or any sort of listening service can interact with that because there's a standard format. And so, yes. Within the cloud events itself, so there's no standard around that, no. But the individual FaaSes will have, well, they will all differ with regards to what they offer security-wise. We're trying to take a more security-centric view of things. A lot of sort of the open source FaaSes are really focused on just the function scheduling and execution, and that's kind of why we built what we did. And then, of course, you've got the public cloud services, which are multi-tenant, multi-user, and absolutely have to have pretty tight controls over that. And so, in fact, that's one of the more difficult things with using something like AWS Lambda is you've got to deal with all the security groups and make sure that everyone along the way can talk to one another, which is good, but it also makes things a little bit difficult. All right.
You can record the web browser though, right?
Yeah. Anything here, fine.
Turn it on. It's better on than off. I'm ready.